Troubleshooting switchgear requires adherence to established standards to ensure safety and effectiveness. These standards are developed and maintained by various organizations, including the Institute of Electrical and Electronics Engineers, the National Fire Protection Association, the American National Standards Institute, and the International Electrotechnical Commission. Firstly, consider the Institute of Electrical and Electronics Engineers standards. IEEE STD 1584.2018 provides a guide for performing arc flash hazard calculations, which is crucial for assessing potential dangers during troubleshooting. Secondly, IEEE STD C37.21.2022 is a standard for metal enclosed low-voltage power circuit breaker switchgear, offering guidelines for design, construction, and testing. Thirdly, IEEE STD C37.22.2017 focuses on metal-clad switchgear, detailing requirements for this type of equipment. The National Fire Protection Association also provides key standards. NFPA 70B offers recommended practices for electrical equipment maintenance, including switchgear, promoting preventive and predictive maintenance strategies. NFPA 70E is a standard for electrical safety in the workplace, outlining safety-related work practices to protect personnel from electrical hazards. The American National Standards Institute develops and adopts various standards relevant to switchgear. ANSI C2, also known as the National Electrical Code, contains requirements for electrical installations, including switchgear, to ensure safety and proper functioning. ANSI CT 4.1 addresses electric power systems and equipment voltage ratings at 60 Hz, which is important for ensuring compatibility and safe operation of switchgear. ANSI C37.10 serves as an application guide for AC high-voltage circuit breakers rated on a symmetrical current basis, providing guidance on their selection and application. The International Electrotechnical Commission offers international standards. IEC 60529 defines the degrees of protection provided by enclosures, known as the IP code, which indicates the level of protection against dust and water ingress. IEC 60947.2 covers low-voltage switchgear and control gear circuit breakers, specifying requirements for their performance and safety. IEC 62271.1 outlines common specifications for high-voltage switchgear and control gear, ensuring consistency and safety across different manufacturers and applications. In addition to these primary standards, several other organizations provide relevant guidelines. NEMA, the National Electrical Manufacturers Association, develops standards for electrical equipment, including switchgear. UL underwriters laboratories, tests and certifies products, including switchgear, to ensure they meet safety standards. CSA, the Canadian Standards Association, develops standards for products sold in Canada, including switchgear. Beyond adherence to specific standards, several best practices should be followed when troubleshooting switchgear. 1. Ensure that all personnel involved in troubleshooting are properly trained and qualified to perform the task safely and effectively. 2. Use appropriate personal protective equipment, including arc-rated clothing, gloves, and eye protection to mitigate potential hazards. 3. Follow established safety procedures, such as lockout/tagout procedures to isolate the switchgear from power sources and prevent accidental energization. 4. Before commencing any work, isolate the switchgear from all power sources to eliminate the risk of electric shock or arc flash. 5. Conduct a thorough visual inspection of the switchgear, looking for any visible damage, defects, or signs of overheating. 6. Use appropriate test equipment to check the continuity and insulation resistance of circuits and components to identify potential faults. 7. Verify the proper operation of overcurrent protection devices, such as circuit breakers and fuses, to ensure they will function correctly in the event of a fault. 8. Check the correct settings on control devices, such as relays and timers, to ensure they are properly configured for the application. 9. If available, analyze data from fault recorders or other diagnostic tools to help identify the cause of the problem. 10. Document all findings and corrective actions taken during the troubleshooting process to maintain a record of the work performed. When troubleshooting switchgear, consider a systematic approach. Firstly, gather information. Collect all available information about the switchgear, including its history, operating conditions, and any recent events that may have contributed to the problem. Secondly, visually inspect the equipment. Carefully examine the switchgear for any signs of damage, overheating, or loose connections. Thirdly, use a multimeter to check for voltage. Use a multimeter to verify the presence of voltage at various points in the circuit to identify any open circuits or voltage drops. Fourthly, use an ammeter to check for current. Use an ammeter to measure current flow in different parts of the circuit to identify any overloads or short circuits. Fifthly, test for continuity. Use a continuity tester to check the continuity of circuits and components to identify any open circuits or short circuits. Sixthly, test insulation resistance. Use a megometer to measure the insulation resistance of conductors and components to identify any insulation breakdown. Seventhly, test protective devices. Verify the proper operation of protective devices, such as circuit breakers and fuses, to ensure they will trip in the event of a fault. Eighthly, check control circuits. Examine the control circuits for any loose connections, damaged components, or incorrect settings. Ninthly, analyze test data. Analyze the data collected during testing to identify the root cause of the problem. Tenthly, repair or replace faulty components. Repair or replace any faulty components identified during testing. 11thly, verify repairs. After making repairs, verify that the switchgear is functioning properly and safely. 12thly, document repairs. Document all repairs made to the switchgear to maintain a record of the work performed. Further considerations for troubleshooting include understanding common switchgear problems. These include, but are not limited to, insulation failure, which can occur due to age, contamination, or excessive voltage stress, leading to short circuits or ground faults. Contact problems can arise from corrosion, wear, or contamination, resulting in increased resistance and overheating. Overcurrent conditions can be caused by overloads, short circuits, or ground faults, leading to the tripping of protective devices. Control circuit problems can result from faulty components, loose connections, or incorrect settings affecting the operation of the switchgear. Environmental factors such as temperature, humidity, and vibration can also contribute to switchgear problems. The use of appropriate tools and equipment is essential for effective troubleshooting. This includes multimeters for measuring voltage, current, and resistance. Insulation resistance testers, also known as megometers, are used for measuring the insulation resistance of conductors and components. Clamp-on ammeters are used for measuring current flow without interrupting the circuit. Circuit tracers are used for tracing circuits and identifying wires. Thermal imagers are used for detecting hotspots caused by overheating components or connections. Power quality analyzers are used for monitoring voltage, current, and other power parameters. Fault recorders are used for capturing data during fault events, providing valuable information for analysis. Also consider the importance of safety precautions. Always to energize, unlock out/tag out the switchgear before commencing any work. Use appropriate personal protective equipment, including ARC-rated clothing, gloves, and eye protection. Follow established safety procedures and guidelines. Work with a qualified electrician or technician. Be aware of potential hazards such as arc flash and electric shock. Switchgear troubleshooting is a critical task that requires a thorough understanding of electrical principles, safety procedures, and relevant standards. By following the guidelines and best practices outlined in this narration, technicians and electricians can safely and effectively diagnose and resolve switchgear problems, ensuring the reliable and safe operation of electrical power systems. Regular maintenance and inspection programs can help prevent switchgear problems and extend the lifespan of the equipment. These programs should include visual inspections, electrical testing, and cleaning. Predictive maintenance techniques, such as infrared thermography and vibration analysis, can be used to identify potential problems before they lead to failures. Proper training and education are essential for personnel involved in switchgear maintenance and troubleshooting. Training programs should cover electrical safety, troubleshooting techniques, and relevant standards. Continuing education is important to stay up to date on the latest technologies and best practices. Switchgear is an essential component of electrical power systems, and its proper operation is critical for ensuring the reliable and safe delivery of electricity. Effective troubleshooting and maintenance are essential for preventing failures and extending the lifespan of switchgear. By following the guidelines and best practices, technicians and electricians can ensure the safe and reliable operation of switchgear and the electrical power systems it supports. Remember to consult the specific equipment manuals and follow manufacturer recommendations for maintenance and troubleshooting procedures. Additionally, always refer to the latest editions of the relevant standards and codes to ensure compliance with current requirements. Switchgear, in its various forms, plays a critical role in electrical power distribution and protection. Its reliable operation is essential for maintaining the integrity of the electrical grid and ensuring the safety of personnel and equipment. Regular inspection, testing, and maintenance are key to preventing failures and extending the lifespan of switchgear. Effective troubleshooting requires a systematic approach, a thorough understanding of electrical principles, and adherence to safety procedures. Switchgear problems can range from simple issues, such as loose connections or blown fuses, to more complex problems, such as insulation breakdown or control circuit malfunctions. A systematic approach to troubleshooting can help identify the root cause of the problem and ensure that it is properly resolved. Visual inspection is an important first step in troubleshooting switchgear. Look for any signs of damage, overheating, or loose connections. Pay particular attention to insulators, conductors, and connections. Electrical testing is essential for verifying the proper operation of switchgear. Use a multimeter to check for voltage, current, and resistance. Use an insulation resistance tester to check for insulation breakdown. Use a circuit breaker tester to verify the trip settings of circuit breakers. Use a relay tester to verify the operation of relays. Maintenance is essential for preventing switchgear problems. Clean the switchgear regularly to remove dust and dirt. Lubricate moving parts to prevent wear and corrosion. Tighten loose connections to prevent overheating. Replace worn or damaged components to prevent failures. Safety is paramount when working with switchgear. Always de-energize and lockout/tag out the switchgear before commencing any work. Use appropriate personal protective equipment, including ARC-rated clothing, gloves, and eye protection. Follow established safety procedures and guidelines. Work with a qualified electrician or technician. Switchgear technology is constantly evolving, with new designs and features being developed to improve performance and reliability. Stay up to date on the latest technologies and best practices by attending training courses and reading industry publications. By following these guidelines, technicians and electricians can effectively troubleshoot and maintain switchgear, ensuring the reliable and safe operation of electrical power systems. The knowledge and skills required for switchgear troubleshooting are essential for maintaining the integrity of the electrical grid and protecting personnel and equipment from electrical hazards. Switchgear encompasses a wide range of equipment, including circuit breakers, fuses, switches, relays, and other control devices. Each of these components plays a critical role in the operation of the switchgear, and a failure of any one component can lead to a system outage. Circuit breakers are designed to interrupt fault currents and protect equipment from damage. Fuses are used to provide overcurrent protection and prevent equipment from overheating. Switches are used to isolate circuits and equipment for maintenance or repair. Relays are used to detect abnormal conditions and initiate protective actions. Control devices are used to control the operation of the switchgear and monitor system parameters. The selection of switchgear for a particular application depends on a variety of factors, including the voltage level, current rating, interrupting capacity, and environmental conditions. It is important to select switchgear that is properly rated for the application and that meets all applicable standards and codes. The installation of switchgear should be performed by qualified personnel in accordance with manufacturer's instructions and applicable standards and codes. Proper installation is essential for ensuring the reliable and safe operation of the switchgear. Regular maintenance and inspection are essential for preventing switchgear problems. A comprehensive maintenance program should include visual inspections, electrical testing, and cleaning. The frequency of maintenance should be based on the manufacturer's recommendations and the operating conditions of the switchgear. Effective troubleshooting requires a systematic approach and a thorough understanding of electrical principles. Always start by gathering information about the problem and the operating conditions of the switchgear. Use a multimeter to check for voltage, current, and resistance. Use an insulation resistance tester to check for insulation breakdown. Use a circuit breaker tester to verify the trip settings of circuit breakers. Use a relay tester to verify the operation of relays. After identifying the problem, repair or replace the faulty components. Always use genuine replacement parts and follow manufacturer's instructions. After making repairs, verify that the switchgear is functioning properly and safely. Safety is paramount when working with switchgear. Always de-energize and lockout/tag out the switchgear before commencing any work. Use appropriate personal protective equipment, including arc-rated clothing, gloves, and eye protection. Follow established safety procedures and guidelines. Work with a qualified electrician or technician.